All right, example 1. Bullet with a mass of 0.035 kilograms, traveling at a velocity of 150 meters per second, strikes a wood block that is at rest, has a mass of 0.7. If the bullet passes through the block and emerges with a velocity of 120 meters per second, how fast will it cause the block to move? So first thing you need to do is what we've normally done, which is just draw a diagram. So we're going to draw a bullet. Apparently it's one of those giant Mario bullets. Okay, traveling forward. It's going at 150 meters per second. You can put the mass down too if you'd like. 0.035. It's going to hit a block. Block's mass is 0.7. It's at rest, so V equals 0. Then you have the collision. Then you have the bullet pass through the block. The block is now moving with some speed, but we don't know what it is. And the bullet is moving still. And its speed is now 120. All right, so there's the diagram. Next thing you want to do is you want to make a chart, kind of like what we did with the X and Y components when we did 2D motion, but this is a lot simpler. You want to make a chart that's got both objects. So we got the bullet and the block. And we're just doing this to organize the information that we have. And the information we have is we have the bullet's mass, we'll call that M1, is 0.035. The block's mass, we'll call that M2, is 0.7. The initial velocity of the bullet is 150. The initial velocity of the block is 0, because it says starts at rest. Final velocity of the bullet is 120. Final velocity of the block is unknown. So you just set up and plug in your numbers just like that. So you're just setting up and plugging in the numbers just exactly like that. What you have, what you're given. And that's it. There's no forces, there's no time, there's no accelerations. It's just mass and velocity. That's it. Just mass and velocity. Lots of mass and velocity, but it's just mass and velocity. Okay. Then you're going to set up the conservation momentum equation. So the impulse momentum equation was for those last problems. We used it every time. F delta t equals delta p. Same thing every time. This time we're going to use a different equation, but once again we're going to use the same equation every time. The equation is going to be this. Momentum of object 1 initial plus momentum of object 2 initial equals momentum of object 1 final plus momentum of object 2 final. So this is super easy once you figure out what those values are. So we need to figure out what those values are. So we're going to find the momentum of 1 initial, which would be mass times velocity. So get your calculators out because you're going to need them for the problems. If you need to borrow one, come borrow one. So this gives me 5.25. Okay, P1 final. It's going to be 0.035 times 120. Which is 4.2. Then we do the same thing for object 2. 0.7 times 0 because it starts at rest. Now here's where it gets somewhat tricky. I don't know what the final velocity is of P2, so I just write it as V. Just write it as V. Okay. So this is just 0.7 V. So don't freak out about this V being here. I know sometimes that makes people freak out because they're like, well, I don't know what to do. I don't know what V is. Don't worry about it. Just plug everything in. So we're going to put everything where it goes in the equation. So P1 initial is 5.25 plus P2 initial, which is 0, equals P1 final, which is 4.2, plus P2 final, which is 0.7 V. And then you just solve. Okay? We got to get V by itself, so we're going to subtract 4.2 to both sides. I'm going to write a little small here because I'm running out of space. So 1.05 equals 0.7 V. We're going to divide both sides by 0.7. And we get 1.5 for the velocity. So there you go. Draw a diagram, label your values, find all the momentums, plug them in, solve. Once you get to the plug-in step, the problem becomes very easy because it's just plug and chug and it's a lot of addition. So you just have to be careful with how you solve it, but other than that, you should be in pretty good shape as far as how it goes. So I'll put this back up here in a second. Go to practice 2. And I want you to circle 1 and 2. And I want you to start with those two problems. They're very, very similar. So number 1 is Mazda Miata is driving to the east. Rear ends another car that's going east at 10. If it has a final velocity of 12.5, what's the other car's? And the other car's final velocity is 17. What was the initial velocity? So same idea. Find out what your values are. Draw the diagram. Plug the numbers in. Solve for the momentums. See what you get when you set up the whole thing. Okay? Number 2 is a bumper car. You got to be careful because we got something going west. So be careful about that. Everything else has been east so far. This is west. So be careful what you do with that. Okay? Go ahead and get started on 1 and 2. I will come around and see what questions you have. I'll give you a minute to start. And then we'll come around and help you out, answer questions, and all that kind of good stuff.